who needs me to do 10? Anyone need me to do 10?
Yeah.
Did someone say yeah?
Yeah.
Okay. I'll just get my pins. Right, so number 10 reads x minus iy plus y plus xi equals 1 minus 5i. Right, so what you need to do is get rid of those brackets first. Right, okay, we have absolutely nothing to do with the brackets. Right, as in we don't need to multiply in, there's no numbers outside, and there's a plus outside. So when I drop the brackets, girls, I'll get exactly what it's written as. Plus xi equals 1 minus 5i. So then you pick out the real bits. So the real bits have no I. So we have x on its own, right? Then we have a plus y and equals 1 over this side, right? That's one equation. Can't go any further with that because there's two unknowns in there. So if there's two unknowns, as in I don't know x, I don't know y, you need two equations, right? Okay, so the other one is, now be careful girls, that's minus iy. It's not plus iy. Then I have a plus xi equals minus 5i, right? So once I have the imaginary bits picked out, you'll notice there's an I in them all, and if there isn't, you've made a mistake. So I knock off the i's. Now, because I'm setting it up for simultaneous equations, I want the x term first, that's coronavirus. X, that's just too dodgy, too soon to be joking, is it? Yeah, so this is all be up on the internet for everyone to sue me. Right, so if you want to tell the judge where the proof is. Right, okay, girls, I normally want the x term first, then the y term, then the number, okay? So I'm just going to move this around, because if I write it as it is, it'll be the y term first, then the x term. So I want the x term first, so that's just x. Then I want the y term, which is minus y equals minus 5. Okay, so I haven't moved them, they were on the left, they're still on the left. Okay, right, so that's, then I do my simultaneous equation, so write one under the other. Which one do you write first? It actually doesn't matter. Okay, so x plus y equals 1, the other one is x minus 1 equals minus 5, right, or sorry, minus y. Right, then you check, is the number in front of the y the same? There is no number, so remember that's 1 and that's 1. Oh, yeah, thank you. Right, okay, so, and then you check, so the numbers are the same, they're both 1. Then you check, is one a plus and is one a minus, right, and they are, so I don't need to change anything here. So I can squash straight away, so plus y minus y gone. So I'll get x and x makes 2x. I have 1 take away 5 is minus 4. And then I divide each side by 2. And I end up with x, the 2's cancel, and minus 4 divided by 2 is minus 2. Okay, so then I have to take any one of those equations. I always take the top one, right? I've just figured out x is minus 2, so minus 2 plus y equals 1. Y's on one side, numbers on the other. Move the minus 2, leave the y. 1 is where I want it to be. Minus 2 comes over the wall, becomes plus 2, and you get y is equal to 3. Done. Is that alright? Okay, that was number 10. Does anyone need me to do number 12? No, great. Number 13? Yeah, number 13. Okay, so number 13 reads a plus bi. Now multiplied by 5 plus I equals 3 minus 2i. So what we need to do, girls, is a multiply first, okay? So we need to multiply out two sets of brackets. So that's split up the first, write the second one down twice. So it's A times the second bracket plus 5I plus the rest of the second bracket, which is plus BI times 5 plus I equals 3 minus 2I. Is that okay? Right? So split up the first bracket, write the second bracket down twice. Multiply out. A by 5 is 5A. A by I is just AI. BI by 5 is plus 5BI. And BI by I is BI squared. And that's equal to 3 minus 2I. So what I do now, change the I squared to a minus 1. So before you do real and imaginary, you have to get rid of that I squared. Right? So the minute you see an I squared, you replace it with a minus 1. So you've plus 5BI plus B times minus 1 equals 3 minus 2I. So that's 5A plus AI plus 5BI. That becomes a minus B equals 3 minus 2I. Okay? Now we're ready to pick out the real bits and the imaginary bits. So the real bits are everything without an I. So there's no I in 5A. There's an I, then we have a minus B. Then I'm going over to the other side, equals 3. Now can't go any further with that because there's two unknowns. I don't know A, I don't know B. So therefore I can't solve the equation. Right? Okay, are they going to jump in on top of my lap? What are they doing? Will you sit down? Right? Okay, so AI plus 5BI equals minus 2I. So I've just picked out the imaginary bits. So it's got an I, got an I, got an I. Right? Everything has an I, so knock it all off. So you get A plus 5B equals minus 2. I'm tempted to send someone up to tell him to sit down. They're settling down now, are they? Are they? I don't know. No, get away. I'm not sending you on a power trip. Right? I said I was tempted. I didn't say I was going to do it. So there's one equation. So the other one is A plus 5B equals minus 2. Right? Remember there's a 1 in front here. Right? So you multiply the bottom line by 1, top line by 5. And remember, when you're multiplying by 1, you're not really multiplying by anything. Okay? Right. So top line by 5, I get 25A minus 5B equals 15. Bottom line by 1 just means it stays the same. A plus 5B equals minus 4. Okay? I've done something wrong, haven't I? What have I done wrong? Have I done something wrong? Have I written down wrong? Because this is not going to work. Yeah, minus 2. Yeah. Okay. And then I'm ready to squash. So I have minus 5B plus 5B gone. I have 25A and A is 26A. 26A equals 15 minus 2 is 13. Divide each side by 26. They cancel and they started again. Equals A equals, they were just settling down and then they start moving again. A is a half. Okay, so take the top line, 5A minus B equals 3. So that's 5 multiplied by a half minus B equals 3. Do it on the calculator. That's 5 over 2 or 2.5 or 2.5, whichever you prefer, minus 3. So then bring it over. So minus B equals 3 minus 5 over 2. Again on the calculator, minus B equals a half. So if minus B is a half, plus B is equal to minus a half. Right? Is that okay? Yeah. Right. And that's as hard as they get. That's a pretty hard one. Okay. Number 14? No, we're okay for number 14. Right. I'm moving on to the next section. So Right, okay. Now you're going to love this. Why? Because it's the minus b formula. You love the minus b formula. Right? So it's quadratic equations with complex roots. Right. So just to explain what the title means, a quadratic equation means it's got a squared term in there. Right? So quadratic equation means it'll be a z squared. We're normally used to looking at x squared. Now we're going to be looking at z squared. Right? Complex roots are the answers. So when you solve, you know the way when you solve the minus b formula there before, you would get x's 1.2 and x is minus 3.7, something like that. You get two answers. X is 2, x is 3. You get two answers, isn't that right? You're still going to get two answers, but they're not going to be real numbers anymore. They're going to be complex numbers, as in it's going to have a real part and an imaginary part. So I'm going to go straight to an example because that's how I'm going to show you how to do it. So example 1. And the question is solve, right? So z squared plus 6z plus 10 equals 0. Now, how do I know the answer is going to be a complex number? Because they use z instead of x, right? Okay? So they use z instead of x. Z has really got to do with complex numbers, okay? So I do my minus b formula. So minus b plus or minus the square root of b squared minus 4ac all over 2 times a. Right, so a is a number in front of z squared. So what's a? 1. B is a number in front of z. What's b? 6. And c is a number in front of, or c is a number on its own. What's c? 10. Right, so you fill in. So it's minus b, so that's minus 6 plus minus the square root of b squared is 6 to b squared minus 4 times a is 1, c is 10, all over 2 times a. Now I know I'm absolutely flew through that, but I know you can fill out the minus b formula. Okay? But the thing is now, you're going to end up with the square root of a negative number. And we know the square root of the negative number does not exist. So if you were to key the whole lot of this into the calculator like you normally do, you're going to get an error message. Okay? So when it's z, girls, you have to just key this bit in to the calculator. So not the square root sign, just the bit under the square root sign. Okay? So you'll end up with minus 6 plus minus, and you're just going to do the bit under the square root sign because it's going to end up as a negative number. How do you know it's ending up as a negative number? Because z is in the question. Okay? So just do the bit that's under the square root sign. So when you put that into the calculator, it will be minus 4. Okay, so don't put in the square root sign, because if you put in the square root sign, it will give you an error message. Yeah, so you just put what's underneath. So you put open bracket 6, close bracket squared, minus 4, bracket 1, close bracket, bracket 10, right, close bracket. Don't put the square root sign because you'll get an error message, because the calculator is not able to deal with complex numbers, right? So it'll give you an error message.
Do you put in the 2 by 1?
No, you'll have to do that yourself. 2 by 1 is 2. Okay? Right? Now, let's go back to the very first thing we did in complex numbers. So we said, right, I'm just going to put this out to the side. So we said the square root of minus 4 was equal to the square root of plus 4 multiplied by the square root of minus 1. This is the very first thing we did in complex numbers, right? And we said the square root of 4. What is the square root of 4? 2. And instead of writing the square root of minus 1, what's this whole chapter about? Imaginary numbers. So the square root of minus 4 can be written as 2i. Okay? So this is me out to the side. I'm just doing this bit out at the side so you can see what I'm going to do next. I haven't dropped the rest of it. Is that what you're going to ask me? Right? So my answer is minus 6 plus or minus, instead of the square root of minus 4, I'm going to write 2i. And that's all divided by 2. And then all divided by 2 means you divide each term by 2. So what's minus 6 divided by 2? What's minus 6 divided by 2? Minus 3. And then I have a plus minus. What's 2i divided by 2? I. 1i, isn't it? 2 divided by 2 is 1. So there's your two answers. One answer is minus 3 plus I. The other answer is minus 3 minus I. Right? Okay, I know it's head wrecking for a minute, but when you see example 2, it'll be better. Where did I get the 2i? I changed the square root of minus 4 into the square root of 4 by the square root of minus 1. Square root of 4 is 2, square root of minus 1 is what this whole chapter is based on, I. So that's the first thing we did. So we changed in the first thing we did in this chapter, we saw that square root of negative numbers can be written as something I. Yes.
Do you know when you're doing the minus 3 and you got minus 6 plus minus 4, what sign did you put in? Like,
You see, when you're doing this on the calculator, you can't put the whole lot into the calculator anymore, because the calculator doesn't do square root of negative numbers. You'll get an error message. So you're not going to type, the only bit you're going to type into the calculator is the 6 bracket squared minus 4 bracket 1 bracket 10. So you're not able to do, you know, the way for regular algebra minus b formula, you put it all in one go. Right, you can't put it all in one go anymore. You can only put in what's under the square root sign, not the square root sign, because if you put in the square root sign, it will give you an error message.
and then for the bottom part, did you just put in 2i plus minus 4?
Sorry?
For the bottom part there?
Yeah, instead of that minus 4, I put 2i. Right, so it's minus 6 plus or minus 2i over 2, and then I divided each term by 2. Right, hold that thought, girls. Wait till we see example 2, and we'll do a few of these, and they'll make more sense after a while. Okay, so I'll go example 2.